All right, are you ready for me to go ahead and start?
Yes, we are.
Okay, great. Well, hello. For those of you that have not met me before, my name is Madison Zulowitz. I am the event coordinator with Dynamics User Group. So I'll just do a quick little intro before you guys get started and listening to your speaker. So just to tell you a little bit about Doug, Doug is a free community for users, implementers, and resellers of Microsoft business applications. We mainly focus on Microsoft Dynamics 365, Dynamics GP, and Power Platform community. And our goal is to help give free education to all of our members to help them grow and excel in their personal and professional careers. Oh, I did not mean to press that. So sorry, everybody. Okay. So our rules of engagement are, we simply ask that these meetups are held to be solely educational. So please no sales pitches. Again, solely educational. We love when people ask questions. So I definitely encourage people at the end of the presentation to ask questions and engage with your speaker. We have multiple different programs with Doug. So we have online open discussion forums, we have webinars, local meetups, as well as regional meetups, conferences, and a YouTube channel where we post other local meetups. So if you're ever curious to see another local meetup or you see an interesting one on YouTube, we would always suggest watching it. We have our 2024 and 2025 regional Doug meetups coming up. We're actually shortly going to be announcing our 2025 calendar for all of our regional meetups. These are a little bit larger in scope than our local meetups like this one. So it'll be a full day of education. They're free events and they're solely in person. So we are hoping to go overseas next year to be a little bit closer to you guys. I know it's a very far trip for you all to come to our regionals because we've only had them in the US and Canada. So next year, hoping to expand our horizons a little bit. But in case you all are curious, the Southeast Regional will be in January, on January 15th of 2025 in Tampa, Florida, and our Canadian Regional is November 26th of 2024. So coming up shortly here, and that'll be in Toronto. We have our Chicago, Illinois 2025 DynamicsCon coming up. So this will be from May 13th to the 16th of 2025. This is our largest conference of the year. So multi-day event with lots of different educational speakers, many great networking opportunities. And Chicago is a great place. I'll be there as well. So we would encourage you to come. It'll be a great day of education. And session submissions are open now. So if you are interested in becoming a speaker, I would definitely suggest signing up. And our agenda is now available for DynamicsCon Virtual 2024. This will be November 13th, so coming up shortly. It is a free event, and the sessions have been chosen by the community. So you all voted, and we listened, and the sessions and agenda are now up. We typically have about 5,000 or more community members register, and we'll be discussing all of the different tracks listed below. And that is all from me. Unless anybody has any questions, I'll put something in the chat to kind of give you a brief rundown of Doug and a little bit more information. But I'm always here if you have any questions about Doug or looking to get more involved. I'll go ahead and pass it over to Rachel.
Yeah, hi, Fasha.
Okay, so I'll be taking the steering wheels from here. Okay, so welcome everyone again, and I'm Funsha, so I'm going to be the host for today. Okay, so if you have any question, just like Madison said, you can simply reach out to her or just send us a message and we'll definitely relay, but she's still here and you can still just reach out to her in the chat section. Okay, so welcome again. I can see Sharon is with us, so welcome also Sharon. And we have Kit here. Interesting. So, Kit, we are glad to have you here today. So, Kit is going to be taking us through an interesting topic. Many of us have been building Power Apps, or you might have heard of Power Apps, and it can be quite daunting when you are building so many components, and at the end of the day, your app starts behaving in a funny way. taking so many time to load and so many things happening in the background. And you're like, how can I reduce so many of these things to actually have my app work in a very smooth manner? So we're going to be looking into the optimization of Power Apps today. And Keith is going to be taking us on that interesting journey. So sit tight and ensure that you are actively engaged. And if you have any questions as well, I'm sure you can also put them in the chat, even if it's related to anything you are currently ongoing with your project, with your Power Apps. You can include that as well. Then we'll try as much as possible to help you. Okay, so thank you very much, and I'll be handing over to Keith.
Thanks, Funsho. Hi, everyone. Thanks for joining us this evening. Great to be here. I'm just going to go ahead and share my screen. Funsho, could you just give me a thumbs up if that's okay, please? Thank you, buddy. That's great. Great to meet you too. Thanks, everyone, for joining us as well. Great few words at the start there, Madison. Really looking forward to those events and really miss in these cold winter nights in Scotland when I used to live in Tampa in Florida as well. But hey, that's a longer conversation. So yeah, just as Funsho mentioned, I'm going to go ahead and talk about some Power App optimization tonight. This is going to be quite close to a presentation I gave at the Power Platform Community Conference in Vegas, which I know not many of us could make it there. So I just wanted to share this session with others as well. And I think this is a great user group to be part of. So just a heads up, who is this guy, British guy speaking to us right now? I'd love if I was actually physically in Malta. It's one of my favorite places I've visited very often. But my name is Keith Atherton. I'm a Power Platform Solution Architect for A&S Group in the UK. I get up to some other training and community work as well. And if anyone wants to connect with me, just go ahead and scan that QR code or search for my name. It's not too common. So I'm quite active, let's say, on LinkedIn and Twitter as well. So what we'll cover today is a few different sections. So the first one will be code optimization with Power Apps. This will be the biggest section. Some architectural optimization, just taking a step back and seeing the bigger picture. User experience or UX, and some monitoring options as well. A little heads up as well, I will be going quite fast in this section, really because there's so many tips and tricks that I wanted to share, and I didn't want to hold any back and just focus on 3 or 4. So really, I'm going to go through these fairly quickly. If any resonate, just please feel free to take a note and dig a bit deeper afterwards if you need to. But also, I do appreciate some of us might be familiar with some of these tips and tricks already, so I won't be lingering too long on any one of them. We'll make some time for questions at the end if anyone's got any as well, and if I don't pick them up along the way, we'll catch up at the end. So first up, we'll look at optimization. Why would we want to optimize? Well, some of the main ways are really to improve that user experience, which we hope will improve the user satisfaction and crucially improve that user adoption. Really, that's the key thing that we want. We want ideally apps that will work so well that they're pleasurable to use. People like to use them. They'll spread the word and become champions of the apps. That's kind of the key. That's the gold standard we want to aim for. Another thing to consider as well, it might be one of the requirements or non-functional requirements of a project that you're working on. It may be that you've got certain response times that you need to meet as part of the project. So there might be key reasons why we really need to hit certain thresholds or time limits. There are certain performance models out there where there are measurements for these as well. So one of the common ones is the Rail performance model, and this was developed by the Google Chrome team a few years ago. And you can tell by their mantra, it's not really to make everything lightning fast, which would be amazing, but it's really to make users happy. So they've done a lot of research and background checking on different metrics such as these, which is what Rail stands for. R for responding to user interactions, A for animations, I for idle time, and L for loading the page content. So while we can see they're not all instantaneous per se, we can see some of them are, reactive enough that it gives a good user experience. And this is after lots of research and studies. So they've defined it doesn't always have to be instantaneous, but within these, kind of limits do work really well. So I'm not saying we have to aim for all of these ourselves, but these are proven to work very, very well. Power Apps, luckily, they do steer us towards performant patterns already. So some of the work is there, like streamlining the data load at launch, automatic incremental paging of data, which we will see with gallery controls and many other things. And we're able to cache data for collections as well. There are many others, but there are many things that help this optimization process for us. Saying that, there are chances of falling into anti-patterns as well. So this might make things go slower than it needs to, things like slow loading times or slow transitions between pages or difficulty updating and retrieving that data, many, many more as well. And some common examples of these, which we'll go into in the main part, is really loading excessive amounts of data. It is possible to do that, and it might cause things to go very slow. Transforming everything into collections might be overkill, might not be needed. And things like overloading the app on start property as well, just doing too much work, which might cause the app to load very, very slowly to begin with. So the 4 key performance design principles that we'll be considering is really optimizing the page loads, small data payloads, just the data that we need, optimizing the query data patterns, and having fast calculations as well. So when we go through the tips in the code and architectural sections, we'll actually see there's actually going to be quite a bit of overlap between many of these. One of the tips might tick 2 or 3 of these 4 principles right here, but these are the main things that we'll be looking at. So let's start off with some code optimization. So we already mentioned there about the app on start property, and just as a refresher there, we can see on the app object on the on start property, the example in the screenshot, we're actually setting a global variable called x to the value of 1. So this does run when the user starts the app. However, as we previously mentioned, it is possible to overload this and do too much work. And this snippet there is a bit wordy, but the short version is that it can cause performance problems when we do too much work when the app starts. And this is direct from the Microsoft Learn documentation as well. So they're aware that they do give us the ability to potentially cause problems by using app on start. So some alternatives that we've got the app start screen property that I'm using right here. So in the screenshot, we can see if we pass in a parameter called admin, set the value to Y, we're going to go to screen 1, otherwise we'll go to screen 2. So by setting this, we're actually determining which screen that we display first, rather than just the default of the first one in the list of screens. And with this ability, we can navigate to a specific screen if we pass in certain parameters, like in the example there, or we could display a custom loading screen if we need to as well. Another alternative, and this is a favorite for me, is the screen on visible property. So when you set the work in here, it's actually the behavior of when the app navigates to that screen. That's when the performance hit takes place, when the work's done. So again, instead of everything on the app on start when it loads and have several seconds to load, this is just as and when we need it on that screen. So if we never go to that screen, we never have to do the work. That's more performance gain. It's a saving, really, if you will. Another one that's become a popular one recently as well, and a favorite for me, is by using named formulas. So we can see there on the app object, we've now got the formulas property. This has been GA for a little while now. And the great thing with using these named formulas, so I've got things there like var word1 is set to, well, it's a constant really, it's set to a string. We've got first user, that gets the first record in the user's data source table. So the great thing with these is that the formula's value is always available, always up to date, and the definition is immutable, which is just a fancy word of saying we can't change that definition anywhere else. But the key one I've underlined there is that that calculation can be deferred. So even though this is in the app formulas property, it doesn't run when you load the app. It's only when they get referenced throughout the app. So again, if you never refer to them, you never get the performance hit. But when you do refer to them, it's like a just-in-time approach. That's when the performance hit happens, when it does the work, and then you actually get the result of running that formula. The other benefit with this as well, by having this on the app object, is that it can improve reuse. So if I want to call that first user named formula that I've got there in 5 different places in the app, I've not duplicated the code throughout the app. I'm just referring to this one named formula. So it's central and it's being reused. And you can take the nuclear option if you really need to, where you can actually disable the app on start property. I've not actually found a need for this. I still do find value in using it. But if for you or for your makers, you do want to disable it, say, look, we've got so many apps that run slow when they start. People are not being responsible the way they use it. There is a way of turning it off in the settings if you need to as well. Okay, some other code options we'll go through. So the first one here, we'll look at the concurrent function. Now the example of code that we've got there, we're actually going to pull from 4 tables and store them in 4 collections. And when we look at the network traffic, we can see they're actually done one by one as we'd expect. So each line of the PowerFX needs to complete before we go to the next one, then the next, then the next. However, if we change this code slightly and wrap it in the concurrent function, they actually all run concurrently, all starting around the same time. So we can see the network traffic, it completes much quicker. It's doing the same work. But if this was app load time on the horizontal axis, we can actually see that this second approach with concurrent would finish much quicker. So really valuable. It's one of probably the key tips for this session, is that is a way, particularly for slow running processes like data collection and things, that's a really good approach just to speed things up. Again, it's useful when the order of events is not important. Right, talking of collections and variable types, we'll look at a few different variable types. So we've got global variables, which have an app scope, and you can reference them from anywhere in the app. So in this example, we're setting a global name variable to the string Oscar, but we can use text, Booleans, records, and tables, and much more. We've also got context variables. Now this has got a screen scope. So this can be referenced from only that screen. And you can also pass them between other screens as context variables as well. So in this case, local energy level set to 100 is just for the screen where it's referenced. And collections at the very end, these are back to the app scope, just like the global variables. So we've got a call accounts collection, and that pulls from the accounts table. So the key takeaway from this is really just to use the most appropriate variable type that you need. If it's just for that screen only, we can use the context variables, and then it's held in memory just for that screen. But if anything gets the global, then it's held in the global memory everywhere as well. Talking of variable types as well, there's another really useful one. I know many of us might know this, the with function records. So these have a formula block scope. So very tightly bound just to the formula, just to this PowerFX that we see here. When we call this, so in this example, we're actually going to do the with function. We're going to look up the user's table for the current user, grab the title, store it in a temporary variable, temp title, and then actually set a global variable afterwards as well. Now, the great thing with this is that once this block is completed, those records are cleared from memory straight away. They're not held in memory anymore because they're no longer required. It's just temporary. The other good thing with these as well is that we can nest with functions as well, make them a bit more complex. Another great thing with the with functions as well is they can massively improve the performance if the record values that you're referring to get used multiple times. So the example at the top there, we've got 3 data source calls. So we can see that we're doing a lookup on the user's table for the current logged in user. We grab the title, first name, and last name. Then we use them with global variables from then on. But we noticed there we've got 3 data source calls. But if we actually just rework the code, refactor it a little bit there, we're actually bringing the entire record back in one call. So now it's gone from 3 down to 1. We actually just refer to the columns that we need after that. So again, if we've got 3, 5, 10 or more data source calls, but they can be consolidated like this, that's a massive improvement on the performance. Another useful thing as well is that they can improve the readability, because effectively we're just breaking down those statements into small manageable pieces. So again, we're grabbing those temporary variables, then doing work with them. It doesn't have to be some big overly complex power effect statement that runs onto multiple lines, we can break it down into smaller pieces. Okay, next up, we'll mention the lookup function. So many of us might have used this if we just want to go ahead, look up. So in this example, we're going to go to look up on the user table, bring back that current user, bring back the whole record, and actually store that as a global user record variable. So that's going to bring us back, if it can find it, just one record. It's not going to do a filter and bring back multiple. It's just going to bring back the one. Then from then on, we actually set a global variable, global user title, to that record's title. So far, so good. However, from the first block, we might notice again, we're bringing that full record back. Now, if we've got a table and there's 100 or more columns on there, it might be bringing back more data than we need, particularly if we only need 1 or 2 or 3 of the columns. So one thing we can use with lookup is the reduction formula property. So this is an optional one. We can see there in the syntax, it's the very last one. So for a while, I was actually just going to a table with lookup, choosing the formula and bring back the entire record, and that's fine. But many cases, I just needed just one, one of the columns, and that was it. So if we use the reduction formula, we can actually just bring a single value back. So we can reference the columns within the table. We can actually do a PowerFX formula as well if we need, but we might just want one of the columns. And again, as I mentioned there, if we don't specify the reduction formula, the entire record is brought back, maybe more than we need. So if I was to rework the example from before, do a lookup on the users table, bring that record back, I'm now saying just bring me the title back. So I'm just bringing back one column. I'm not bringing back the whole record. And that's the only column I need. So it's fit for purpose now. Along those lines as well, in terms of retrieving table data, this is a brief look, just a snippet of looking at the users table. However, as we mentioned, some of these tables, particularly some of the system ones, they might have a lot of columns. In this case, over 120 columns in this table. So again, there may be cases we bring back the entire record, but we maybe don't need all of the record. In fact, many cases we don't. So one way of just bringing back the columns that we need, this first example, we bring back all of the users table into a collection called co-users, and this will run on and on and on. Not a lot of data to see there, but all of the columns are being brought back. Another example of reworking this is actually using the show columns. So right now, if we're going to bring all of those back from the users table, but we only want the full name and the primary email, we're now just being explicit. We're just bringing those two columns back and storing it in the collection, which is a lot less memory required of that collection to hold the data. Another thing just to mention related to this as well is we've got something called explicit column selection in Power Apps, or ECS. So this is where Power Apps, they've tried to be very helpful and say, hey, I noticed that using full name in a label on that screen, I'll bring you back the full name column. So it's trying to be targeted and helpful in which data it brings back. However, on my experience, certainly as of maybe a year ago, sometimes it was a bit temperamental. It wouldn't always bring back exactly what I needed. Maybe it was just my use case, but I found that sometimes, even though it was in use on the screen or in a control, it wouldn't always bring that data back. However, if you do use the show columns approach, you're the one being explicit in which columns you want returned. So I've found it's always reliable. Works very, very well. So we've talked about the columns that we need. Just a quick look now in terms of the table rows that we need as well. So this example right here, again, back to that similar example, I'm going to go to the users table, bring back all of those rows into a collection called core users. In this case, there's 146. It's not crazy, but it might be more than we need, particularly when we see a lot of system users listed in the table. They're not the relevant ones I want to display for the users in this case. So one example we can use is by using a filter. In this case, I've just filtered it to the city where I live, Edinburgh in Scotland. And this is just a way of saying, just bring me back the 17 rows in this case of just those records that I want. So it's another quick win of saying, well, one, I'm only showing the relevant data to the end users, but two, it's much faster because it's now a filtered, reduced record set as well. We can also do the same in terms of galleries as well. So we want to use Dataverse table views for this. That could already do the filtering for us ahead of time. Here's an example where I've got a gallery, gal all users, and I've picked my data source as the users table. So far, so good. We've brought back all of the rows, 146, all good. However, again, if I've got a view that is pre-filtered or pre-sorted as well, I'm able to pick that view for the gallery and say, just bring back those rows that I need. So again, super, super useful, just targeting the rows that we need. One thing I should mention with this as well, while I've called out Dataverse table views, other relational database systems, they do offer that as well. SQL Server, which really is what much of Dataverse relational tables is. It's really just Azure SQL under the bonnet anyway, under the hood. But also Oracle, MySQL, many others as well. They've got the concept of views. So you could also use it with other data sources too. And another option, you could actually reach out from the Power App to Power Automate to populate the collection as well. So this example I've got right here, we're going to look at the accounts table. We specify the columns, always a good approach again, just the columns that we need. We're filtering it, can make a massive difference. We've targeted something here based on the date, created on greater than a certain date. We've got some sorting and some other work going on as well. So this can be really good if we want to offload the work away from the app to keep the app super responsive and snappy and let some other process doing it. However, the downside of that is that there's likely going to be some performance cost to doing that, because essentially we're offloading the work to something else. It's not seamless within Power Apps. And now we're going to call a Cloudflow, it's asynchronous, and there's a performance hit. That's really because when we launch it, it's got to have its own memory allocated as well. So it's really what the right use case is for you, for that solution. It may make sense to use a Cloudflow in this case. It may make sense in other cases to keep it within the app and just, have the app do the processing for a short while until the results come back. Depends on the solution. Another option is to cache the data where possible, and this can make a massive difference as well. This is really useful. So cache, just a fancy word for saying we're going to store the data in memory. So any of us who are gamers, who played games or developed games, we realize that many games, they take a while to load at the start. That's because it's putting most of the data in memory for the app. So when you play the game, it's snappy and responsive because it can call it from the memory that's held in the cached memory. It's not having to go back to disk or over the cloud to bring the data back and delay the performance of the game. So that's kind of how it works. By using the same approach here, we can do it by saving the user's record to a variable in this case. Back to that lookup example of just a specific column value. So saving it to a specific variable, or saving multiple records to a collection as well. Now, the great thing with this is that if we refer to this cache data, instead of going back over the wire to the data source each time, as you might guess, it's going to be much, much, much faster performance because it's actually held in memory at the app on the client side. So it's super, super fast. One thing we need to consider with cache data, though, is, well, one, it's going to take up the memory in the app if we do that. Unless it's large amount of records, that's not probably going to be too much of a problem. But bear in mind that that data may get stale. So how often does that data change? So if that data is changing very, very frequently, caching may not be the best option. If it's just going to be there for, it's going to get updated once a day overnight, then it's maybe safe to hold it in memory. And again, is it real-time data that you need to consider as well? It's all worth considering for your solution. Another useful tip as well is a way of patching records very fast. So many of us might have seen this example on the left. This is how I would commonly do it when I started. We'd use a for all, we'd go through a collection, in this case, call accounts, going to go through them one by one, and then call a patch statement for each one. In this case, I'm going to create new records. It's kind of a bit meaningless. It's a silly example, right? They're all test account with number 1, 2, 3, but we're going to go through them individually one by one. However, there is an approach called a schema match approach where you can do them in bulk. You can see its last code. We've already built this call accounts collection. We can just do the patch on the accounts table directly, just go in, and they actually all run simultaneously. it's much faster. So there's some good articles. Matthew Devaney's got a good article. Microsoft Learn, they mention this as well. It's worth looking into if this is something you do quite commonly. And also, I'll give a few notable mentions as well. So things, anything that we might consider over-engineered or complex as well. Some other random tips right here as well. So avoiding cross-screen dependencies. So this is where you might reference a control from another screen. When you do that, actually both screens get held in memory. And there can be some delays or drag or some performance hits because of that. So again, the approach we had where we use context variables, if you go to another screen, you can actually pass the context variables across, and that's a way that they're located just to those screens, and they're not both held in memory. If you do anything clever with galleries, you can nest galleries within galleries. If you want some kind of expand, collapse, or clever view, there are ways of doing this in a single gallery instead of using that approach as well by using some power effects and setting the visible properties and so on. But when you do nest them, it can be quite slow for performance as well. In terms of galleries as well, there is the gallery all items count, which is relatively new, but that's quite useful. Where before, if you needed the account, you actually have to get everything, all items, and then run a count rows on it. Right now, we've got a very handy, convenient property that we can call. Considering screen transitions as well, a friend of mine made me aware of this one. So many of us might be using fade or cover to go between screens. There are many devices out there that might be lower powered, older devices, older mobile devices and phones that people use, or slower data connections, depending where people are based in the world. So really those transitions, that simple animation, that could actually be quite slow and cause a bit of lag or a bit of jitter. So in many cases, if you don't really need the transition, a quick one is just to have no transition at all. Avoid overusing timers as well. I've seen a few solutions where a screen's got multiple timers, and Power Apps are good only so far with timers, and sometimes it can add a bit of again jankiness, a bit of jitter, a bit of delay. So if you can consolidate to one timer, or ideally no timer at all, that's the preferred approach. Considering the data source refreshes, if this is something you do in conjunction with a timer, or you do it every time you save a record, you're refreshing it to update the gallery. Considering how often that can be, again, it can take a long time to perform that data source refresh. If using any offline features, we do have the Power Apps offline native feature where you don't need to code your own load data or save data approach. That was the previous approach before we had this. It's much more performant in many cases to use the native feature. And also publishing your app regularly as well, because every time the Power Apps engine gets updated, there can sometimes be security and performance updates with that as well. So something as simple as owning it in the designer, hit republish, you're going to get the benefit of the latest updates. So we have covered a lot there. So appreciate there's a lot of information, but again, I know many of us right here, we might be aware of some of these, so I wanted to get through them quickly to share any that you might not have come across before. So next up, these are smaller sections, but this is going to be architectural optimization. So things like considering the media that we upload. So many of us might have uploaded things like images, audio, and video files to a Canvas app using this pane that we've got right here. So some things to bear in mind are there are some size restrictions. And again, this is almost some kind of guardrails that are put in for us by Microsoft. So that way we don't upload anything crazy large. It's going to take a long time to run, like a kind of 2 GB video or something crazy. So we do have some limits that are there to protect us. Bear in mind with images as well, if you can use SVGs or scalable vector graphics, they are typically much lighter than PNGs, JPEGs, or anything else, because they're really just using vector maths to design the image, and they scale very, very well and keep that crispness as well, where the other ones are a bit more bitmap based, and they tend to be a bit heavier, a bit larger in size. And also, if using Dataverse, consider using those image thumbnails where appropriate. So if you're showing records in a gallery and you just need a small manageable thumbnail, just a small image that doesn't need to take a lot of size, then you can use those auto-generated image thumbnails. They give you a URL to use, which can be very, very useful. Talking of media as well, if anything's not used anymore, there are convenient ways of cleaning these up in Canvas apps. So we do have a few handy buttons there. So automatically removing any data not currently in use. You don't need to go through one by one and check your dependencies. You can just do that and it's done for you. Same for the unused media and same for any unused flows as well. So again, just really convenient ones. You don't need to go through them one by one. It'll actually do the work for you and clean them up. Another thing as well is the app checker. And actually, the first time I built this presentation, I actually forgot about this just because it's part of my it's just part of my process. I just run it at the end as I just took it for granted, right? But when you get to the end, you get this little stethoscope that's showing up there. If there's any badges or any dots on there, they show us things like any issues with formulas, runtime, accessibility, performance, and data sources as well. So just by going through that, you might get some quick wins. So right here, I focused on the performance. We've got 12 warnings. 10 of them are unused variables. They can just be hacked out of there straight away. They're not in use. And 2 of them are actually cases of where the rows retrieved from the data source might not be complete. And the great thing there, it gives you the example of how you can fix that and why you need to fix it as well. And again, sometimes it might be removing something unused, or it might be saying, hey, there might be a delegation warning here. It might be truncating the data that comes back. Another thing, taking a step back as well, is considering monolithic design. So my background is a pro code. I've been doing pro code for over 20 years. Lots of .NET apps, web apps, WinForms, things like this. Lots of SQL Server and Oracle as well. Very common with pro code because you can kind of build anything you want really. That's good and it's bad as well. You know, sometimes you might build a big app and it just gets added to and extended over time and grows and grows and grows. May not start out that way, but it might end up that way over time as well. So a monolith is really a big app that does multiple different things, maybe more than it needs to. It's maybe overgrown. So one good approach is to split this up into microservices or smaller apps. And typically each one of those apps does one thing very, very well. That way they're all targeted, they're all performant in their own right. And you don't have this big heavy lifting app that's trying to do too much. That takes over a minute to open because it's grabbing too much data and doing too much work. If you do need to navigate between these apps, it is possible as well. So let's say if we had, in this case, 7 small apps instead of one big monolithic app, you can actually use the launch function to deep link into those other apps and pass any context variables as parameters if needed as well. So if you're in one app and you need to go to another one and actually open up that specific record, you can do that by passing in those parameters, and the other app, when it receives those params, it can actually open and navigate to the screen that you need it to and open to that record. So we can make it responsive if we need. Some other useful Canvas app settings, many of these might be on by default already. We've got things like using the new analysis engine. This is really for us as makers. This is not for the end users. This is where we'll get the full performance benefits using the designer, the Power Apps Canvas Studio. Keep recently visited screens in memory, again, another form of caching that we mentioned, and optimizing for devices, specifically mobile devices. So again, when we actually build those or using wrap or get anything designed for the mobile device, you can actually harness it, the capabilities of those specific OSs. So Android or iOS, very, very powerful if you use them. Model-driven app considerations. Appreciate I've been giving a lot of love here for Canvas apps. That's really because Canvas apps by default are very customizable, which means we can do anything we want, but we can make a lot of mistakes or fall down into anti-patterns as well. Model-driven apps are great because they really do a lot of protective work for us because so much is just generated off that data model automatically. So many things are done really, really well. I'd have to say there's a lot less considerations we've got for model-driven apps. But nonetheless, here are a few. We've got things like the default tab. When we go there, those controls are going to have initialization logic invoked when you load it. So if you've got a very busy, big default tab that goes on and on, you need a scroll bar, it's really busy, they all need to do their own bits of work and have their own memory associated. It's going to do a lot of work. So you may want to split them across multiple tabs. Data-driven controls. Many of us that use quick view forms, subgrids, timelines, there are many, many others as well. Anything where really, if we think about it, they're actually doing other lookups or joins to other tables behind the scenes. They're doing their own data pools themselves that are out of our control. So if we're using them, again, we use too many of them, they may be doing lots of work, maybe too much work that might be causing a delay when the app loads or when you navigate between pages. JavaScript, right? We could do a whole session just on JavaScript alone. So there are many things here in terms of memory management, how the code's formed, are there any busy loops or greedy algorithms? I'm not going to get to the pro code craziness that I could do, but some of the key ones are things like using asynchronous network requests when you pull data. Things a bit like the concurrent we saw in the Power Effects, offloads the work and gets back when it's done. We've also got things like the solution checker. This can analyze client and server customizations for performance and reliability issues. We've got performance insights, which was preview last time I checked as well. And we've got things like object checker as well. It's another thing that is in preview last time I checked. But again, I think these are just going to improve. And a bit like the app checker we saw in Canvas, it's going to give us, hey, consider this. Hey, here's how to rewrite this and improve this. Really, really good. Other things as well in terms of us as makers or developers of optimization that we can use when we build things as well. So there's a commonly used concept been around for years with pro code, which is dry or don't repeat yourself. And again, this comes back to the reuse instead of duplicating the effort. So you might be able to consider reusing items if you've got named formulas. Again, that's one central place, could be used throughout an app in many, many places. Components as well, if you use those within Canvas apps. I want this menu or header or footer to be used on multiple screens. That way I've built it once and it's reused. If I change that one place, everywhere else benefits from it as well. If you need those components used across multiple apps, we can then just abstract that back to a component library as well. So that one library could be used in multiple apps. Good for headers and menus and things like that. We've also got user-defined functions, which is still experimental. I've been recently chasing Microsoft about this. Can we please get this GA? Super, super useful. They did, yeah, I can share this. They did let me know that it is experimental now, but it is on the cards to release fairly soon GA. Now, these are really just named formulas with parameters. That's all they are. It's the same thing, but we've got that extra feature, extra capability with them. And we've also got low code plugins. Again, another thing I keep nagging and chasing for because they're super, super useful. Now, these are, for me, I really love these, even as a pro code background, is because with typical data first plugins written in C#, they're automatic. You create a new account record in the table, they get fired. The great thing with these low code plugins is they can be automatic, but you can call them instantly as well from Power Apps within a snippet of code. So again, it's another way of keeping a reusable code library you can call from anywhere, and it's in Power Effects. So it's not just geeks like me, it's going to be anyone who can write Power Effects who's going to be able to create and maintain these. Super, super useful. That's a win-win. Really love that. Okay. So another thing as well, in terms of the data model as well, many of us might have to design these. This is designed to, it's not intended to be readable. It is crazy, right? This silly diagram. But in terms of over normalization, I'll come on to what normalization is in a moment. But on the left, I've worked on a lot of projects with Oracle, SQL Server, MySQL, and many others. And typically we'd normalize it as much as we could. So every entity has got its own table. We don't have reuse or duplication anywhere. There's no redundancy. However, with Dataverse, I actually learned the hard way about this on an early app, that actually sometimes we need to simplify that data model and not overly normalize everything. That's because the more normalized it is, the more joins and links between tables there are, which means more work to be done, and it can have a performance impact. So a little brief on what normalization is. I appreciate most of us, many of us here might know what this is, but data normalization means, again, you're storing the data only once, you don't have duplication or redundancy, and that way the data is consistent. So if we've got a list of, like say, international speakers, Sharon Smith's one of them, she's joining us on the call today, who's going to be speaking at an event this evening as well, a New Zealand event. you've got Sharon just mentioned in one table once. It's not mentioned in 2 or 3 different places. And that way, if we do an update, we need to update all those multiple places. So with this, we're keeping it in one place only. However, from the Microsoft Learn documentation, they even do mention that for Dataverse, sometimes you may need to duplicate some of that data to make the queries faster and easier. Now, for this is a bit anathema for me. This is the opposite of what I've been taught when I started, is that you'd never want to duplicate because, again, you need to now update in multiple places, or you need to maintain it and keep it updated in several places. But again, the reason for this is really balancing the 2 goals for the app design and the table structure to avoid too many links and too much performance hit with the lookups. Related to this as well, and this is how I found out the hard way, is actually I did have one core table once, and with all of the status values and everything, they weren't choices, they were lookup tables. I had 8 of them that looked up to other tables, and loading the data in the gallery went really, really slow because it was doing all these lookups for every row. Painful, really painful. I had to rein in that data model and kind of refactor a lot of the code. So this pattern's sometimes known as n squared, or it's more commonly as the n+1 problem. And this, again, is just because of these lookups, it's having to do extra work. One way to get around this is denormalization, as mentioned above, or you could use views that perform those lookups themselves as well. And sometimes it might be trial and error, depending on the data volumes of what works well for your app. In terms of duplicating the data, again, we mentioned some reasons there. If it's too slow to access, if it's stored in a different location or format, again, some people might be speaking, they might have data sources in New Zealand, Australia, in India, US, Europe. It may be that you want to locate it a bit more local if you find that the performance hit is just making it too slow to retrieve. Or you might want to consolidate it, that first name and last name brought into a full name. That's why we sometimes have those kind of calculated fields. To make the query faster, you can copy that slow data and store it locally in a table or in an environment that is local to you. That's easier to query. Another way of keeping these updated is some kind of background process as well. So you might want to periodically run something like a Power Automate Cloudflow that keeps that data refreshed on an hourly run or a daily run, whatever the case may be. Data flows, they can be scheduled too. You might use a plugin, so it's a bit more automatic, a bit more just in time. Or things like SQL Server stored procedures. Again, you can use the agent there. You can use a job that runs on a schedule as well. One thing to bear in mind, this is back to the cache data that we talked about, is that local data, if that is just a daily refresh, let's say, but the data updates once an hour, you might have to bear in mind that the data might get stale. You might be using out-of-date data if you are using this approach. So it's one thing to bear in mind for the solution that you're working on. One other thing to mention as well is relatively recently, we've got this Dataverse long-term data retention as well. This is where we can move. We can see from the diagram data that's active, which we commonly have in tables right now. You can move it to inactive data after a period of time, and then you can actually delete it permanently at the very end if it's no longer needed. So this is another option. Let's say if you've got data volumes that build over years and years and years in an enterprise solution, you've got something where it approaches tens of thousands or hundreds of thousands or millions of rows over time. But really the active is such a small subset that there's a big delay when you run your filter or your view to pull the data. You can actually move it into this inactive data store. So that way, if in 7 years' time you get audited, or there's some kind of compliance that you have where it needs to get queried in some way, it is still possible. I find it is a little slower pulling from this inactive data store, but it is an option if you do need to kind of archive that data in a way. One thing to note as well, it is a managed environment feature. So one thing to bear in mind in terms of licensing, it's one of those fancy bells and whistles that come with the managed environments. Another thing as well, this is quite a simple thing really, is just, are your users close to where the data is located? The graphic I've got there is these data locations for Power Platform environments, where they're located in the US, Europe, and across the world. So consider that when that environment's created, what region is created for that? And really, regions behind the scenes are really just Azure data centers. So you might choose something like West Europe. It might be the one in Amsterdam. That might be the data center that's used. And there are ways of finding that out as well. Also consider where you've got any on-premise data gateways as well. It may be that, again, I'm working here in Scotland, but I might actually be dealing with a US client and they've got their own local network with an on-prem data gateway and they're based in West US or something like that. So there may be that extra lag of going over the wire to where that data is located. And also where we've got other data sources located as well. Again, if we're using anything hosted in the cloud, let's say an Azure SQL database, and that's again hosted in a resource group, and that RG is based in a certain data center somewhere in the world, we've got to bear in mind where that data is located. It might be doing a lot of round trips to get the data that we need. So I was going to do a quiz, but I know many of us here know our stuff, right? So I'm just going to say, if we're using a Canvas app, we've got different data source options. So let's have a look. We're going to have an online data source. Let's say it's Azure SQL database. Let's say it's local to us, all good. We're going to have an on-premise data source. Let's stick with SQL Server, one of my favorites, so I'll pick that one. And also Dataverse as well, part of the Power Platform. So some people, I actually asked this when I was actually there physically running this when I was in Vegas and just asking the crowd, and there was a good mix of results of what people thought might be the fastest data source. So to go through all three of these, the online data source, we need to go through 2 layers to get to the data source. So we're going to go from the Canvas app with a connector, go through API management or APIM, go through the connector, then we're at the data source. But also that response needs to go through both layers before it returns to the Canvas app. Now, if we go to an on-prem data gateway, even if it's your local network, we're now actually going between cloud and local network, and that traffic needs to be managed. So we've got 3 layers. We have a 3rd layer now, APIM in the connector, but also the data gateway itself that manages that security in the traffic. And again, the response needs to go all 3. However, when we go to Dataverse, that's a direct connection. We don't even need APIM for this. We go direct to it because it's just using an OData request and it's part of the Power Platform. So using Dataverse is the winner, right? Well, it is in terms of connection because we're going to get there quicker and not go through all of these layers on the request and the response. But the other thing to bear in mind is also what you're doing at the data source as well. So if you're someone who's quite familiar with database development, I did many years writing stored procedures using user-defined types and things on SQL Server, placing those table indexes where I wanted them to be. It's something that might be, I'm able to fine tune that to the knowledge that I've got anyway. There'll be people who know much more, but if that data pull is actually done at the data source much, much faster, it doesn't matter what the connection to the data source is too much because it's been optimized at that data source. So there's really both parts to think of. Okay. And in terms of data operations as well, one thing, the D word, delegation, many of us might know about this already, but really delegation, just a bit of a primer here. Delegation is where the Power Effects query, again, let's say at the Canvas app, that query is actually being performed at the remote data source. We've delegated the work to the data source, done the work there, and just brought back the results that we need. So the great thing there, it's done on the big, powerful server, and it's only bringing back those filtered records and the data that we need for it as well, instead of the entire table and then doing the work in the app. So there's a win-win here because we've encapsulated the data being brought back. We only bring the subset we need, but also it's going to be much faster because there's less data going over the wire back to the Power App as well. So it's, again, a win-win by understanding how the delegation works. Delegation can be used for many data sources, some of them like Dataverse. Again, this is going to be a first-class citizen. It's part of the Power Platform. SharePoint, SQL Server, which again, really is what a lot of Dataverse is anyway, and also Salesforce and others as well. And by seeing these tables that I've got a snapshot from Microsoft Learn, we can actually find out what capabilities are delegable. So if I look at this one here, this one's for Dataverse. If I actually want to run the equals comparator on a number, I know it's going to be delegable. But if I'm going to do search on a number, it's not delegable. So in other cases, I might want to use an alternative, one of these comparison operators or a filter or something else. And one thing that goes hand in hand with delegation really as well with Canvas Power Apps is really the first up to 2,000 records. It's 500 by default. It's just the first 2,000 that's going to be brought back from the data source. So again, if we pull from a users table and there's 3,000 users there, but we want to bring the whole table back, we're just going to truncate it and bring the first 2,000 back. So it's quite a serious problem. Again, right, I know we're rattling through this, but we're getting towards the last couple of sections here. So I'm going to wrap up with a few things on user experience. Some of us might have seen this in apps, not just Power Apps, but busy UIs, where we've got lots and lots of controls. One thing to bear in mind is that these controls need their own memory each. So again, if there's lots of controls, lots of memory, it might make things go a bit slower. Now, one thing we can do here is bearing in mind the gallery control. So if we're repeating anything, by using a gallery, we're just using one control. So even if things repeat, and the great thing with that is we can repeat business data, almost like this example in this very crazy looking UI right here. But anything else that repeats, such as menu items as well, using a gallery, we're repeating it, a consistent look and feel, but really the gallery is going to be one control. Another thing as well, if you just can't avoid it, we can always consider splitting busy screens into multiple screens or into multiple tabs in model-driven apps as well. Another thing in terms of if something is going slow, let's say it's a big data pool, we can't avoid it. It's going to take a few seconds. We need to do something about it. It's always great giving users feedback. Hey, please wait. This is going to take a while. One of those options is the out-of-the-box spinner that we've got. So things like screens and galleries have this. We can control the loading spinner that we've got and also the spinner color as well. It's a little limited, but it can be quite useful. But you can also upload your own animated GIF into the media section and use that as well. I know some customers who do this by using their own organization's logo and just by using PowerPoint or something just to make it spin or fade in and out, pulse in and out, just to give that a bit more branded touch. Also with modern controls, they've got their own spinner as well. I quite like these because you can add this text label to it and control it. But if you look at the style and theme in the screenshot, there's a lot more control over the aesthetics as well. So you set your own fonts, the sizes, the weights, but also the position of where that text is around the spinner as well. Really useful. Favorite for me is the progress bar. Now we've got two options here. Like the spinner, we can have the indeterminate one, which will keep going until the job is done. But the determinate one is really good. Anything where you might install an app and you can see it's 10%, 20% done, and you can determine when it's going to be complete. The determinate one is really, really good for that, to say, again, give that expectation for the user of like almost there, and then they know when it's almost finished. Another thing that can be useful in Canvas apps as well is for text inputs. We've got this delay output property as well. So this, when it's set to true, the example I've got in the screenshot there, that only registers after half a second delay. So if you're typing something in, say someone's name in this search field right here, this is good that it's not going to perform the big search work on every keystroke that you make. It's only when you finish typing and your hands off for a half second or more, it knows, okay, now I'm going to do the work. And it does the work then ad hoc, just in time. So it's a good thing, again, just to stop a slow performance on every keystroke for a search. Again, the good example there with the gallery, we're searching through names or searching through data. So just to wrap things up, this very brief bit is going to be about monitoring. Let's say we've got a performance issue. The app's loading slow, it's sluggish. Users are not happy, tickets are coming in. A few options we've got really is the Power Apps Monitor. So if we bring this up, we can see a lot more detail there in the screenshot. We can see every operation that's done. We can see the status codes, duration they took, and much, much more. So the good thing is we can use these when we're building apps in the Power App Studio as we're making them. So something's not right here. Let me just fix this. The other benefit is that we can actually run them against published apps as well in runtime. So something's in production, go slow. I can't reproduce the issue in dev, for example. We can hook up a monitor session to this published app and still monitor all those interactions and operations that happen. With these things, we can check many things. I mentioned there, things like duration, but also things like errors, the response that goes out, the request that goes out, sorry, and the response that returns. We can drill into the JSON, the payload. What happens? What's going wrong? Why is it going wrong? And you can access this using App Checker or go into the advanced tools as well. One other thing just related to that as well is the trace function. I've got an example here, the syntax, but also my example just saying hello world. I've set the severity, and I've also just created a record with an ID and a name. So this is great. If we want to record our own diagnostic information from behind the scenes, we can put things there or include variables, include some other information. And we can get to that from the Power monitor, which we've got in the screenshot showing right there. We can see it showing in the message with the other info provided. But you can also see it in Test Studio and Azure Application Insights as well. You might need to use KQL to query it amongst all the other operations you can see, but you can actually see it in those several places. I've also written some Power Effects snippet, which feel free to use. This is something where I might not need to see every operation that's ran, but let's say if I've clicked a button on the onSelect, several operations are ran, something's going really slow, I don't know what it is. I can actually just wrap the whole Power Effects with this snippet start and end, and then just notify to the user how long the operation takes. Then go ahead and change my Power Effects, run this again, and see, is it now quicker or slower? Have I improved that code or not? So it's just a quick way without having to go into the monitor, just say, just give me a number. How long is this taken in seconds? And just to finish up, if you really, really need to, I've not had to use this since the Pro Dev days. I've not had to use it for Power Apps, but you can measure the memory consumption graphically using the browser's development tools as well. So if you need to see the graphs, you need to see things like nodes, listeners, heap sizes. Again, this is really when you look after your own memory management and use lots of different complex moving parts. But I'd say for Power Apps, I've not really needed this. This is really handled for us in a great way. But if you do need to go to that level, and again, personally, I haven't with Power Apps yet, there are ways of doing it using those browser dev tools. So we've covered a lot there. Just to recap, we covered lots of code optimization, some architectural optimization, user experience, and some monitoring tools as well. So we've reached the end. If you're still with us, thank you for your time. I really appreciate it. I know there's been a lot covered there. If you do have any other questions, do connect with me online. And I'm always happy to help. Just connect with me on LinkedIn or Twitter. And yeah, thank you very much for your time. I'll pass back to Funsho and see if we've got any questions.
Wow, thank you. It's actually a lot. I see some pointers there, some that I've used, some that I'll start using now. Yeah, so it's actually very expository, and I'm quite glad that we could even reach out to you even on the LinkedIn and Twitter platform. And I think this call is also recorded, so you would also find it on the DUG YouTube channel. Yes, it's going to be there. We'll share the link then it's going to be accessible for everyone. I can see Rajesh has left, so I'm sure he would want to revisit that. So if you have any question, you can unmute your mics. If you are shy, you might not share your screen. That's perfectly fine. So any question? Let me look at the chat. Okay. Thanks for notifying it. Okay. No question. Okay.
There's
Wow.
a lot of info.
Yes, it's actually a lot of information. Yeah, so many to digest and to go over them.
Absolutely.
So it's perfectly fine. We need this because that's why we are here to develop ourselves and even have assignment for ourselves. But really, you've touched on so many things, and even there is one tool I usually use for also monitoring, and this is especially when you are trying to also check for optimization on mobile devices. So it's called the Fiddler trace. So there's a way I get to connect the Fiddler to the network on mobile, because troubleshooting on mobile can be a bit difficult. because the mobile app is playing and you need to basically read the optimization, read the load time and some telemetries. And it was only via the Fiddler trace that one could actually do that. So I used to do that using the Fiddler platform to enable that possible.
That's a great tip. Yeah, thanks, Funcho, because yeah, you're right. There are some other sort of maybe more pro code related tools, and that's a great one. And I think that's a good example as well you mentioned, because when you're on a mobile device, typically it's a lower powered device. It's typically a smaller screen. It's typically, it may access the data network in a different way. So yeah, it's a great example there of why you might want to use it on those devices, because hey, I've got a big powerful desktop machine here with a big display and it works great. But if I'm not doing the actual testing on the actual device that the end users use, they may get a different experience. So yeah, thanks for sharing that. It's good.
Yep. Thank you so much. Okay, I think that brings us to the end of this month's meetup session. So thank you very much. I'm going to definitely be following Kit back to back. And also Sharon here. I've been following Sharon from afar, so glad to see Sharon join us today.
My pleasure. My pleasure.
Yeah, thank you so much. And Rachel, thank you also for organizing this.
Yes.
Okay, so I think that brings us to the end of today. So thank you very much, everyone, for joining us today. We are really glad to have you. So we'll see you next month. Okay. So
Great. Thanks for your time,
much.
everyone.
Yeah,
Thank you.
Thank you.
Thanks,
you.
Bye all.
Bye.
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 Bye.